Okay, so this last part will show you how to run Snakemake in a HPC, so high performance computing environment. Right. So to give you a bit of background on what an HPC is, it's an aggregated computing resources that allows greater performance than a single computer or a single workstation. So on the right, you've got a small figure showing basically what an HPC is, but you can think of this as a lot of very powerful computers linked together and on which you can share jobs and workloads. And each node, each compute node has a lot of CPUs and a lot of RAM, usually. So it's very efficient to run computationally heavy processes, and also it can be used simultaneously by multiple users, which is what you will do in the next few minutes on the server. Each HPC has a job scheduler, for example, Slum, that is here to manage jobs, all the jobs sent by the users. And the idea of a job scheduler is that it receives all the jobs and then choose when and where to dispatch them, to start them, and for the jobs to be processed. The idea is to minimize the downtime of each node. Um, Using an HPC and using Snakemake on an HPCs will require a few extra configuration steps like RAM usage, number of CPUs, runtimes, and so on. That being said, you will see that it's not that hard and you don't have to change that many things. So here we're actually showing like the difference of executing a simple Python script locally, so in which you just do Python parse your script and you're done. But if you want to do this on a cluster, so for example, here it would be a cluster run with Slum, you have to use the sbatch command, which is actually the job submission command. Then you need to pass the memory you allot to the script, the number of CPUs, the runtime, the partition, and so on. And finally, you can actually put your command, so Python myscript.py. This can be turned into an easier, let's say, format. You can have a bash script, so .sh script, with all your parameters and values in them using the sbatch, so hashtag sbatch string, and all your parameters. And the last line or the next line should be the command you want to execute. And if you have a script like this, what you will do instead is actually sbatch the script itself instead of doing this, submitting this directly on the command line. Snakemake can interact with a lot of schedulers. So we've got a list here. The most famous ones are AWS from Amazon, LSF, and Slum. Slum is the one we will be using today. As I said, you don't need to change much to actually run Snakemake on an HPC, because the scheduler can actually infer information from the rule definition. So for example, if you give a rule a certain amount of memory, the scheduler will pick it up through Snakemake. It does, however, require to change one key parameter, which is -j or minus jobs, and that's the maximum number of jobs that you can run in parallel in Snakemake. So if you don't change this, even if you have the most powerful computer ever, Snakemake will only run one job at a time. And so the the way to activate the cluster mode, let's say in Snakemake, is either through the --cluster option in Snakemake version 7 and before, or after version 8, you need to install a plugin and then use the dash dash executor and scheduler name in the Snakemake command. Now to further optimize this and actually run job on HPC cluster, you need to do two things. The first is checking how much your rule need to run, the resource requirements, and then how you can optimize this resource usage. Because when you're on a cluster, you will pay for computational time, memory use, and so on. So the more you waste, the more you pay, actually. So you have to be aware of this. So we'll start with the benchmark directive. So it's, once again, a new directive. We'll see another one after that, but it's quite similar to the log. So it takes a file path as value. And what it does is that Snakemake will measure the runtime and the memory usage of the rule and save it to the file. So if you have no idea what are your requirements, you can run your workflow once or a part of your workflow to have the benchmark, and then you can check these benchmark files to see how much your workflow need to go and to work. And then you can optimize your resource usage. Once again, benchmark files must have the same wildcards as your output, so be aware of this. And same as logs, the best practice is to maybe put all the benchmarks in the same folder. Now to actually optimize the resource usage, you can use the resources directive. So that's the last one we'll see today. And the goal of this directive is to set some values for a job. And it's a new kind of directive value. It's a pair of key and value. So we always have key equal value. So for example, memory equal something. So you've got a few examples here. One is mem underscore unit, so it can be megabytes, gigabytes, and so on. And you can, for example, set it to one here. And the other one is a runtime. So you have many resources available, including, for example, GPUs, but these are the two that are used most of the time. Once again, when you've got several statements in a directive, don't forget the comma between them. So jobs resources are determined as either it can be determined in two ways. The first one is if you actually specified resources in the rule, Snakemake will use them. If you didn't, Snakemake will use some default values that are shown here, and won't customize or do anything to your goals. You can also extend the default resources when you call Snakemake. So set a very global parameter in the Snakemake command line. One thing to keep in mind is that job submission has a cost, albeit small. So sometimes some rules are so small you don't actually need, I don't know, 48 CPUs or something to run them. So in this case, you can force Snakemake to execute them locally using the local rules keyword. So you can either do it like this, with the local rules keywords and the rule name, or you can do it with a directive, local rule column true, to set this rule as a local rule. The last thing I want to mention is about configuration profiles. So one way to make this whole HPC run easier is to use configuration profiles, which will contain pre-configured configuration parameters, such as the resources, the executor, the type of, like whether you need to use Aptainer or Conda to deploy environments. You can also add some execution parameters. How do you want to submit jobs? How do you want to check the job status? How do you want to cancel jobs? Things like this. And so you can do everything, all these things within a configuration profile. There are two types of profile. One is a global profile. that sits in the .config/snakemake folder. It will be applied to all the Snakemake workflows. The other one is a workflow-specific profile, and it should be in a folder within your working directory. As a general rule, we tend to prefer workflow-specific profiles because they're easier to manage and also they're more adequate to manage resources. All these directories will contain files in YAML format that we saw earlier, and here you have a link for an official list of all the Snakemake supported profiles. So yeah, so for example, when you create your profile, you can create like my profile folder and then create a YAML file inside it. And I'll show you a few things that are usually like the minimum configuration that you need to have. So the first one is the executor. That's basically the scheduler that's running on your HPC. So here we will be using cluster generic because it's a bit more customizable and it's a bit easier to use. But you could also use the Slum profile as well. And that tells Snakemake how to communicate with the scheduler. The second thing is the cluster generic submit command, and it's a command to use to run the job. And in this command, you can actually add some configuration related to your cluster. So in the case of a Slum cluster, that's the sbatch command that is used to submit jobs. And here, for example, we also add a name for each job and also the number of threads to use for each role. And that's like the very important parameter I mentioned before. So maximum of jobs that Slum and Snakemake should run concurrently. And so it takes an integer as value. So that's quite useful to avoid overloading the cluster, because right now we're only like 25 users. Imagine a cluster with tens of nodes and hundreds of thousands of users. This can go very bad very quickly, so beware of what you're doing. Once you've set up your profile, running Snakemake with it is just a matter of one option, Snakemake -- profile, and then the path to the profile folder. And that's all, basically.